Well, hello everybody, and welcome into the Great Atmosphere Show for on this January 8th of 24. We got ourselves a little bit of a four-alarm fire in the contiguous U.S. from a synoptic weather point of view. Before we get started, though, just want to encourage you to make sure to subscribe to the channel. Specifically, I make weather forecasts on a synoptic and occasionally mesoscale basis, big and small weather, I'm going to try to do every weekday. We're going to try to make that happen, mainly for the southeast United States, as that is where I'm currently based and I have the most experience in. Not saying I won't touch on other parts of the country throughout the course of the videos, but that's just my experience. So I just want to make sure that everyone knows that from the outset and be honest with that. So taking a look at what we're looking at today, we, as I said, it's a little bit of a cornucopia of different events going on in every corner of the U.S. Mainly, as we take a look at this the forecast, we always start from the upper levels of the atmosphere down, because the upper levels dictate what goes on in the lower levels, where obviously we live. So this is looking at 250 millibars or hectopascals up in the atmosphere. Very, very quite high. Upper levels of the atmosphere. And these are jet streams. Now, in the northern hemisphere, there are two primary jet streams. There is the subtropical jet, which obviously kind of goes around the Tropic of Cancer region. And then we have the polar jet, which usually in the summertime stays up here in northern Canada, but occasionally will dip down into the northern United States. And bring above that Arctic jet is polar air, which would be, or Arctic air, I should say. So it's kind of like the upper atmosphere boundary for extremely cold air. Now, what we have, usually these two jet streams are very different and they're very separated from one another. And that's where we get our nice United States temperate atmosphere that we typically experience on a day-to-day basis. Every now and again, things happen such that both of the jet streams merge. And when that happens, it creates kind of a domino effect in terms of energy, because that energy from both jets, they don't cancel each other out, they amplify one another. So as we can see from right here, we see our polar jet, which is typically around this latitudinal boundary right here, is actually going to dip all the way down into, what is that? That's southern New Mexico and central Texas. And the subtropical jet is actually a lot further north because of our current very strong El Nino. And El Nino moves a lot of moisture and winds from its general vicinity here in the southern basin underneath Mexico, or south of Mexico, and moves all that moisture up and over the Yucatan Peninsula into the Gulf, enhancing it more over Florida, over the southeast, makes us very wet. So those two, the cold of the polar jet and the moisture of the subtropical jet, have merged. And we are in quite a bit of a doozy going forward. So this is currently what we're looking at. We see a pretty significant trough that has set itself up here in the base, or not the basin, the lee of the Rocky Mountains, going all the way up from Montana down into New Mexico, and it is creating a little bit of a fuss. So typically when we have storms such as this, it's differences of pressure and temperature and moisture that ultimately spark big thunderstorms. And this is not a departure from the norm either. Tis typically what we have, and usually we have blocking patterns in the northern hemisphere, which makes our area in the contiguous U.S. a little bit more stable this time of year, with like more mild and more dry air. Such is not the case this year. So typically we'll see big clockwise moving motions of high pressure out here in the Atlantic, northern Atlantic, and the northern Pacific. And ultimately that suppresses a lot of energy of low pressure systems that would otherwise come through like a bowling ball through the United States. As you can see, you don't see those giant high pressure clockwise moving centers for a variety of reasons, but we'll get to those in a little bit. But the end result is you have these little ones. So you see the counterclockwise motions are low pressure systems, which is where we typically see big storm systems. So we see one here in the middle. That's our big troublemaker today. We had our one that was a big nor'easter in the northeast that happened this past Saturday. And look out here in the Pacific. We have 1, 2, 3, 4. There's a bunch. And all of those systems have the potential to be troublemakers here in the U.S. because there's nothing high pressure wise blocking them beyond one that is currently sitting off the central coast of California. And that's ultimately not really blocking anything. It's just kind of getting in the way of the two jet streams that we saw in the previous page. And you can see that kind of right here. So we got probably another 3, 4, 5 different systems that are very clearly all lined up here and will be coming in succession over kind of a period of every, probably 3 or 4 days. Taking a look at the water vapor that we currently have, so we see it's generally moisture throughout the entire course of the United States right now. Deep blues, greens, and whites will denote a very moist atmospheric environment, with the oranges and reds being dry air. Obviously, if you want a storm, you got to have moisture in place in order for rain to happen and for convection to occur. So we see that general motion of the storm system. We see a little bit of that cold air that comes in behind the low pressure starting to build in on the into western Texas and New Mexico right now. And then we see it's currently a lot of Gulf moisture is going and putting up into the Mississippi River Valley. That's where we are currently seeing a little bit of some snow and icing conditions. And then we have our subtropical jet primarily providing us some moisture over the far deep southeast of the U.S. at the moment. As I said, it's kind of a mixed bag and a bear in terms of, in terms of what we have in store for us. This is the all hazards map put out by the National Weather Service, and you can see all of these different colors correspond to a different warning that the National Weather Service has put out for each specific region of the U.S. Reds would be denoted as blizzards. So we can see here Kansas, Nebraska, Colorado, and panhandle of Oklahoma and Texas experiencing a little bit of that of some blowing wind. We have our next system that'll be affecting us in the Pacific Northwest. I saw actually pretty incredibly. This is the first time in over 10 years that the National Weather Service office in Seattle has actually put out a blizzard warning for both the Olympic Mountains and the Cascadian Mountains up there in the Pacific Northwest. Pretty interesting little tidbit right there. And I from what I saw earlier this morning, they were calling for 8 feet of snow to fall potentially in the Mount Rainier region of the Cascades over the course of 36 hours, which is quite incredible. So we have, and the browns will denote usually wind. So we have high wind warnings pretty much consistently across the entire southeast, south, Montana, and upstate of New York. We have our first major freezes going on in SoCal and southern Arizona. We have flood advisories going all the way up into the Mid-Atlantic and Northeast, specifically in the deep south and lower Mississippi and the New Orleans side of southeastern Louisiana. We have gale warnings everywhere. We have just a lot going on at the moment. So, one thing you want to keep in mind, though, is that we are very privileged to have the National Weather Service here in the United States. There is no other weather service in the world that is as informational and public and, most importantly, free, and it's local. I think there's about 151 or something along those lines, different offices that dictate different county warning areas around the country. So if you don't have bookmarked or saved or following your local National Weather Service office in your neck of the woods, you're really doing yourself a disservice, because you're not going to get a better forecast from any app or from, technically speaking, not a dig on the broadcast meteorologist, but usually most broadcast meteorologists, than what you're going to get from the National Weather Service. They are degreed meteorologists, that's whole profession is to warn the public and to provide decision support services for a variety of governmental and private institutions. And they do it all free of charge. It's all part of the U.S. Department of Commerce. So I really do encourage you to look up where your National Weather Service office is locally, and be sure to follow all of the dictations and reports that they put out on a day-to-day basis. That will really, really help you in terms of getting educated about your specific area. Taking a look at what we're looking at from a radar perspective, radar reflectivity, we see some of those storms starting to pop up. Dew points are still relatively low in this area. We need those to accelerate a little bit higher in order for our major, our major storm system to start getting going. But you can see this rain-snow line. This is going to be a major point of contention over the next 24 hours as forecasters in these regions decide where the snow is going to be and where the rain is going to be. It's going to be quite difficult to suss out. Not something I particularly envy. It's almost as difficult as what the Northeast had to go through a few days ago in developing that rain-snow line, but they actually did a pretty good job over this past weekend. So as I said, we got a little bit of a stream of moisture going across north central Florida at the moment. Then we have some scattered showers into Alabama, Mississippi, and central Georgia. Ozarks, Arkansas, northeastern Texas, getting the brunt of the severe weather at the moment. Here at that's about 2:00 in the afternoon on East Coast time here on the 8th, and we're going to move forward with what we are looking forward to in the next 24 to 36 hours. This is what the Severe Weather Prediction Center out of Norman, Oklahoma, has currently predicted for the Southeast. This is the day 2 outlook. Now, this area right here in the Lake Charles, New Orleans, Southern Miss, and Mobile areas, they are under the gun for severe weather going into tonight. That is actually quite a dangerous setup, because the nocturnal low-level jet, which is the primary moisture transporter that gets activated usually in the overnight hours, is going to shift into overdrive as we move into the overnight hours tonight, and should provide quite a bit of severe weather in that region. Tornadoes, heavy rain, and very severe wind gusts. We are not going to focus on that because this is a southeast channel at the moment, at least. So we're going to move into what's going to be affecting us throughout the day tomorrow. And you can see here in the panhandle of Florida, we have a elevated risk. This is the tornado outlook. So if you're in the yellow, you're looking at a 10 to 14% chance probability of a tornado within 25 miles of a point. So you have to, that's 25 miles is kind of what you would call the margin of error. So if you are in this specific scenario, let's say, Raleigh, from the map point of view, is in the brown, but you can justifiably say, hey, I mean, the yellow is 25 miles away from the center of downtown Raleigh. Technically speaking, that Raleigh is in the margin of error and is not in the 5 to 9, it is in the 10 to 14. So you got to keep that in mind. Also, the hatched area represents strength. So if you are in a hatched area, which is the majority of if you are in the yellow area in this scenario, that you have a 10 to 14% chance of it being a tornado that is of EF2 strength or higher, which is, all tornadoes are devastating in their own right, but EF2s and higher are particularly devastating, and they will it starts to become a significant risk to life and property. So if you're under the gun, which is quite a significant amount of people, definitely continue to pay attention to not only this video, but also to the local and National Weather Service stations and your local broadcast meteorologists as well. They only want to keep you safe. So got to keep this in mind. This is also another big aspect of tomorrow, which will be severe wind. So much higher chances in this scenario. You can see that we have now there in the red regions a 30 to 44% chance of a probability of severe wind, and the hatched areas a greater than 10% probability of significant wind gusts greater than 74 miles an hour, which is hurricane strength winds. So if you are in any of those hatched regions, and if you are specifically in those red hatched regions, definitely need to batten down the hatches a little bit. We have quite a significant squall line that's going to be moving through that we'll take a look at here in just a second. But this is what the National Weather Service does all the time in the Severe Weather Prediction Center. So they create these graphics that are very easy to read, and they give people a general understanding of what they are to expect in the coming days and even weeks. So let's take a look at what we are looking at from a energy point of view. So this is the 250 millibars, so pretty high up in the atmosphere look going into tomorrow. So what we look at in this scenario is we see our big upper level low that is currently set at this moment in time. I have this in the, what is this? It's 0Z on Wednesday. So this is Tuesday evening, about 6 p.m. ish. And you can see what we're looking for here is difluent flow. So we see these very close together isobars right here. It's when these isobars spread out in different directions and they start to become, the space in between them becomes greater, is when we know that the going up into the atmosphere, the air is diverging away from one another. Okay, kind of like a fountain. All right, and when that happens, it leaves a void in the upper atmosphere, and the atmosphere doesn't really like voids. So what does it do? It has to pull that extra air from somewhere. It pulls it from the lower atmosphere, and when you pull from the lower atmosphere to the upper atmosphere, what do you get? You get convection, you get energy, and that's ultimately what creates thunderstorms. So in this scenario, I'm just going to kind of play around here a little bit as we go forward and backward in time. You can see that we have plenty of energy here in the upper levels, and you can see significant wind gusts up, that's well over 100 miles an hour, 129 knots about, as we get into the Appalachian Mountains. And then we also, if we have the energy, we also need to look at our moisture. So you can see these are dew point values. Dew point is a representation of the moisture that is currently in the atmosphere, and you can see going in through today, you see that nocturnal low-level jet. That's what it's called here in the 850 region of the atmosphere. You can move that up to 700. It'd probably be about the same if I had to guess, but they don't have a dew point one, probably because it's not supposed to. Okay, so you see dew points here at 850. They're going to go all the way up, and we're going to get here in the southeast quite a significant amount. I don't even know if they have a value here. 12 degrees Celsius. That's pretty high for the winter here in the southeast. So we're definitely going to be nothing short of moisture, precipitable water values in the atmosphere. It's kind of like how much water, if you were to take a chunk of a cubic, 1 cubic meter of the atmosphere, how many inches of water would be in that cubic chunk. We have about, I believe the last time I checked, it was about 1 to 1.2 inches of water in every cubic inch of the atmosphere, or cubic meter of the atmosphere, which is quite significant for specifically the winter, just because in colder temperatures, the atmosphere doesn't inherently hold as much moisture. So when it gets up to that amount of moisture, you know that it's a quite loaded precipitative environment. Words. Moving on, we're going to see that energy and what is causing a little bit of our problems coming forward. So what we're looking at in this is relative vorticity. We're looking for little ribbons of energy here. I guess that's the best way to put it. So you see the blacks represent cyclonic vorticity, or cyclonic vorticity advection, and the blacks, or the purples, I should say, cyclonic vorticity advection, and the blacks anticyclonic vorticity advection. And when they're close together like this, that is another indicator of divergence, because they're going in two separate directions, and this is how the computer tells us that specifically. And one thing that we're going to look for is little ripples in the lines, and they probably don't mean much. They don't look like a lot, but obviously we are small people that experience things on a much bigger scale. On this particular map, it seems like a smaller thing, which is totally understandable. Maybe we can zoom up and we can see how significant these little shortwave troughs are, if they even have this. They don't. Sad. But effectively, those short waves are what are going to be the initiators, the spark that gets these thunderstorms started, and they are quite significant in their own right, and they are quite spread out as well. You can see little dots of them throughout the course of it. That denotes discrete supercells, which is quite a dangerous phenomenon in squall line patterns like this, because you'll have your primary squall, your big line of thunderstorms that you'll see on the TV as you're as it's coming to you, essentially. A big wall shelf cloud is usually associated with it. But every now and again, out in front of those walls, you have little tiny storms that are still going in the same direction, but they're out in the middle of this very warm atmosphere. If we go back to the dew point, so looking at our dew points again, you can see kind of where that squall line is. You can see the pretty severe gradient in color. That would be where the model depicts the primary focus of the storms to be. You see changes in wind direction. You see winds going from west to east here, and then from south to north here. That is quite significant. And then obviously the gradient represents very moist air compared to dry air that is just funneling in behind it. What you see here, though, is that that's just the primary squall line right there. That's obviously where your winds are going to be, your primary winds. But ahead of that, as we saw in that vorticity chart from before, this is the juiciest atmosphere you could ask for in terms of convection and moisture. And you got all the storm relative helicity that we talked about. This is prime tornado threat numero uno in terms of what you would expect from a discrete thunderstorm. And when I say discrete thunderstorm, I mean the thunderstorms, the tiny little dots that appear on the leading edge of some of these storm systems that come through, specifically with squall line patterns. So as we can see here, this is kind of a reflection of what the NAM 3-kilometer surface reflectivity or radar is, what the computer thinks the radar is going to look like, not necessarily going to actually look like this. This is all still probability based, but going forward, this is what they expect. You can see that squall line pattern. This is about what time? 16Z, so about 1 o'clock in the afternoon on Tuesday, tomorrow. And you can see out ahead of the squall, you can see little tiny dots of red that just pop up every now and again, up and around. And those dots can be, specifically right here, these are problems. Okay, so we have a thunderstorm that is surrounded by moisture, fully in a convective mode, has the wind shear necessary component. That's the danger zone, and that's what the National Weather Service is mainly concerned about. And you can see this reflected in a sounding. So what a sounding is, excuse me, is essentially a weather balloon. So National Weather Service, every National Weather Service office, 153 or whatever it is, number of them, launch 2 weather balloons a day, one at midnight, one at noon. And what those weather balloons do as they go all the way up into the very upper echelons of the atmosphere is they take readings. They take temperature, dew point, winds, whatever it might be, all the way up in the atmosphere to give us a good snapshot of what that atmospheric column looks like. And we can use that to create point-by-point forecasts. So in this scenario, we have a number of different things to look at. The primary thing we want to see is that 0 to 1 kilometer helicity, which is primarily denoted by shear. So what happens typically when you have a sheared pattern, you can have directional wind shear, which is kind of what you see here in the sense that in the bottom lower parts of the atmosphere here at the surface, you have the winds coming from the south-southeast, and then a little bit further up in the atmosphere, you can see that wind barb denotes a south-southwesterly wind component. So there's a little bit of directional wind shear, but probably the most important in a tornadic environment is speed shear, which is denoted as such. So let's say in the upper atmosphere, you have really, really strong winds, like so, but then in the lower atmosphere, you got kind of, still pretty strong, but not as strong, just kind of piddling along like this. So that doesn't look like a whole much of anything, right? But if you look at this from a physical point of view and that there's air in between these two layers of the atmosphere, you can see that over time, air here will start to kind of go like this. A little bit of a cyclonic or an anticyclonic clockwise formation here. Kind of like so. And over time, this gets represented in kind of like a spiral helical pattern. So you have kind of like a wind tunnel that forms in between these layers. And as I said before, we had quite a bit of convection here as denoted by the dew points. So if we have high amounts of convection, which is denoted by our velocity models here. Okay, so we have quite a bit of energy, so a lot of lift. That spiral of energy that is currently horizontal is going to naturally get lifted and become vertical. And what do you call a vertical spiral of air near the surface that goes from the surface all the way up to the atmosphere in a very concentric way. That's called a tornado. So that is our primary concern here, specifically in these little tiny dot regions coming before the squall line. The squall line itself is going to be very windy. That's where your potential for tropical storm force winds is going to be in place. That's going to be a major troublemaker as well. Definitely batten down the hatches and make sure everything is nice and secured before that happens. But first, tornado is a big threat going into tomorrow. Definitely want to make sure that everyone that hears this has a way to receive tornado warnings. That can be from the National Weather Service via NOAA Weather Radio. That can be from a broadcaster. That can be from literally any major weather app. You can turn on notifications and tells you if your county warning area just got put into tornado warning. You need to have something, because it's lucky for the Southeast to have this during the day. They're not going to have the same. The far deep South is not going to have the luxury that the Southeast has going into Tuesday. Talking about tonight for them, this is going to be in the middle of the night. Everybody needs an avenue in order to receive these alerts, so they can wake them up in the middle of the night, or it can interrupt their workday, which I know some people just kind of get tunnel vision and they go straight forward into their workday. You need something to break you out of it in case something crazy happens from a tornado point of view. But the other major thing that's going to be occurring here is the amount of rain that'll be coming with the system as well. It's going to be quite a bit of excessive rainfall. This is just what's precipitated on the eastern seaboard over the past 72 hours, which includes our major nor'easter storm that occurred on Saturday and Sunday. We're looking these values. Everyone got about an inch and a half of rain. I know with my weather, my CocoRa's weather gauge outside, rain gauge outside, I got about an inch and a half, which is pretty well reflected here in the NAM guidance here for the past 72. So you put inch and a half, 2 inches in some places like this. That on top of what we are expecting here in the next 24-36, as put here with the NAM 3 kilometer. You can see we're just going to get dumped on yet again. There's going to be a little bit of a flooding risk as well throughout the course of the day. Not the entire course of the system is probably going to last about 18 hours. So 18 hours to get about another 2.5, 3 inches of rain. It's quite significant, because that just puts us in like the 5-6 inches of rain category over the course of the past 5 days, which is quite a lot moving forward. So we just got to keep that in mind. Local rivers and whatnot might overflow a little bit. I don't think it'll be a major flood event, except in extreme circumstances. You're going to see that mainly on the in the Blue Ridge Escarpment, and also in the foothills of western North Carolina, as a lot of snow melt actually comes down and couples with it. That'll be a big problem up in the Northeast. That's going to be a major flooding issue, specifically in North Jersey, the upstate, and Western Mass. But specifically here in our neck of the woods, it's going to be mainly on the western edge of the Blue Ridge, which is going to be the primary focus of the rainfall amounts, but certainly something to keep an eye on moving forward. We're going to take a look at the plumes, good old plumes. They're going to be, this is just if you don't know, this what we talk about quite consistently here as a short-range ensemble forecast plumes. They essentially give you a sense of the confidence that the forecasting, the various different ensemble models and measurements are predicting for a very specific region of the United States. So I'm just going to kind of bounce around here and see what happens. We'll look at here at Charlotte Douglas. The spread highest amounts about 2.7 inches down to 1.6 inches. Median would be about 2.1. So about 2.1 inches here in Charlotte. But I mean, if these models were closer together, let's look at another one. There's better ones. So you can see temperature. Okay, so if these temperatures are very, very close together, you can see that the model guidance is very confident that it's going to be in this range. And then you get over into, let's see, 16Z on tomorrow. It has a little bit of less confidence because they're more spread out going into the early morning or the late morning hours of tomorrow. And that can be reflected here. We're looking at total quantity of precipitation from this whole event. It's looking for about 2.1 for Charlotte. Looking up at Hickory, about a little bit higher, 2.6. Obviously, we're going to get higher amounts as we go further on. Hendersonville, south of Asheville, is looking at about 3.7 inches of rain. That's quite significant. Expect quite a lot for the Nantahala, getting close to 3.5. And then we're going to go a little bit further to our east. Look at Wilmington. less rain in that scenario, but more of a severe risk, obviously, as we mentioned before, about 1.5 inches. Raleigh looks at a little bit under 2 inches as the mean, but confidence can go 2.5 all the way to 1, so we just got to be mindful of that. Roanoke's about 2. Then we can go a little bit further south. We go to North Charleston, about 1.5 inches. Quite a big spread there from 2 all the way down to only 3/4 of an inch. And we'll go down to Jacksonville as well, just under an inch, but look at that spread. That's 1.5 all the way down to barely anything at 3/10. So definitely something to keep an eye on is the amount of rainfall going into this. Also, we talked about how the models have performed recently, and we saw that earlier on in the first week of the year, they did exceptionally poorly in terms of the short or the medium range of getting our nor'easter system out and about and in place. They didn't do too great, particularly the GFS kind of pooped the bed in a lot of respects. Only was accurate to a 76 percentile range. Not great for that 90% that we were looking for. Back up to normal areas in the 95 percentile accuracy range for both the Euro and the GFS in red, Euro in blue, going into this. So we're gonna have a little bit more confidence. They did a very good job in terms of predicting snow output up in the Northeast, which I think is the main indicator that it's kind of back on track. So that's kind of the end of the analysis for what's going forward. Definitely make sure that everyone has a way to get severe weather warnings and issuances from the National Weather Service straight to your phone. That's going to be the most important thing. Make sure everything is charged. Those are pretty severe wind gusts. You got wind gusts and tropical storm force, even hurricane storm force wind gusts up to 74 miles an hour. Those will bring down a power line or two, and especially since the soil is it's so saturated right now, tree roots are going to have a hard time kind of staying in place, specifically on rolling hills and valleys and that kind of thing that you would see in the far western Piedmont and the foothills in North Carolina and the upstate of South Carolina. Definitely something to keep an eye on. Got to take a look ahead just a little bit and kind of get a little understanding of what is in store. And we talked earlier on in the video about what this looks like from a northern hemispherical level. So typically we have these, this is a big high pressure system right here denoted with these big dark oranges to reds and then whites. Those are high pressure systems. Those are typically in place usually around a little bit more further south here in the northern Atlantic and in the northern Pacific. You don't see any of that in the northern Pacific, and you see a big one, but way up here in the Scandinavian and Greenland Islands and Iceland. So what that does is essentially it pushes air that would otherwise be very cold and whatnot here in the Arctic down wherever these troughs are. So you see this nice little path of no red. That means that all of that is just going to be a giant channel for cold air moving forward in time. So here's our system. You can see the system that's going to be moving here in the next 36 hours. And you can see that blocking pattern still does not really show its face. You can see it tries to get its act together here in the Atlantic, but the Pacific is just a mess. So you see those little dots of blue everywhere. Those are just new storm systems that are just going to form, and you can see it just go boom, 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 straight in. And then we even get a little bit of a scenario of cold air getting trapped down here, and that's going to be kind of what we talk about here in the next bit. And why is this the case? Well, it's because the polar vortex is a little bit lopsided at the moment. This is supposed to be one concentric ring. This is looking up at 10 millibars up in the atmosphere. This is stratospheric, okay? So way up in the atmosphere, the thing that dictates most every weather pattern here in the southern and or in the northern hemisphere. Typically, it's supposed to be one big white donut right here over the Arctic. Not the case. We have a relatively high, strong ridge of high pressure or high pressure center that is currently over southwestern Alaska that is pushing all the polar vortex energy over a little bit further to the relative east in this scenario. And that's kind of throwing a lot of things off, and it's creating this a little bit of a conveyor line effect. And you can see that spread here into the United States of that cold air that is sinking from the stratosphere all the way down into our neck of the woods. And that's reflected in our 6-day temperature outlook. Look at this. The Climate Prediction Center out in, I believe they're in Silver Spring, Maryland, they are predicting well below average, near 90 to 100% certainty of below average temperatures going into the next 6 to 10 days from January 13th to 17th, issued on the 7th. So definitely something to keep an eye on. These areas I know for a fact are going to, here in the blizzard alley of the north central plains in Montana, they're going to experience highs that won't get above 0 for multiple days in advance. And this is very concerning because from a life-threatening point of view, they're going to be getting multiple rounds, as I said, of while we're dealing with severe thunderstorms here in the southeast, they're going to be dealing with nonstop snows. And snow has been kind of an anomaly in that of itself for the past couple of years for the entirety of the country, including the Midwest. And in this scenario, there are parts of Missouri, Kansas. Trying to get out of this. Parts of Missouri, Kansas, Arkansas, Iowa specifically, eastern Nebraska. These areas are down to get probably about 1.5 feet of snow. And when you have that in place, along with temperatures that are not going to get above freezing in some respects, that snow is going to stick around. Let's say, and if you don't have power because of the amount of wind that's coming through with all these, I mean, you don't have somewhere to heat your home. This is a pretty significant threat to life. Or let's say your car breaks down on the highway and you have to stay there overnight and you don't have any heat in your car or no blankets. I mean, like, people die that way. So it's a very big concern going forward and for the Midwest in the next few days. And definitely these temperatures are going to shift quite a bit below normal, even in our neck of the woods as well. Just taking a look further of what I'm looking at in the next probably 10 days or so weather-wise. So we have our main system that's going to be moving through here if it wants to load. There we go. So it's the system from today and to tomorrow. This is also the GFS global model and the Euro on the right, just to kind of see what both are thinking at the moment. Deep blues represent snow, obviously rain for the green, and the orange and the red for thunderstorms. And then we're going to get a little bit of some more stuff. We have a couple of, as we said, we go into this little 2 to 3 day break, and then we're back with another one. Next one will probably be about Friday and Saturday for us. The low center seems to be more northern than what we've been accustomed to recently. So that one's going to go all the way up deep and over the Ohio River Valley and move up into the northeast, into Lake Ontario and Erie, before going up and out. But what that does is it fills in all of this is essentially just a big channel for that cold air. So this giant area of high pressure that we're seeing fill in after this system that comes in on Friday, Saturday, that's going to be some of our coldest temperatures that we're going to experience. And then after that, our next system comes in, definitely more of a more southerly component, because this air is so cold. In order for a low to form, it needs to be against wherever that warm to cold temperature gradient is. Obviously, now it's a lot further south. It starts forming here, and this is where our potential new problem is going to set in. Blacks or browns and light browns, that denotes ice and sleet. And you see, we're seeing a pretty significant, timing's a little off from both of the models, but this is more than about 7 days out, which is a little dicey. But it just gives us a good opportunity to kind of look and just see what we have to keep our eyes out for. Ice throughout. GFS expecting some ice in the on the eastward facing slopes of the Appalachians, but the Euro, which has admittedly been a little bit, or actually quite a bit more accurate in this 7 to 10 day range for the global model recently, expecting a much further south ice event. And you can see that it's going to make its way not only into the Appalachians, but also Mississippi, Alabama, and the deep south, and then move its way further into the Piedmont and North Carolina and Virginia as well. So, and snow for the most part all the way up through here. So when is this? This is midweek. This is about 7 days from now. Definitely need to keep an eye on this. This is at least what the models are saying is going to be the next big potential for snow. And this is kind of the event that meteorologists have been predicting based off the climatological guidance over the past few months. El Nino kind of makes ourselves a little bit open to this. This is what the Euro is expecting from ice accumulation over that time frame. You can see it starts in Texas, moves forward in time, and I wouldn't pay attention to much of the values. I mean, if they got 0.8 of an inch of ice in these areas, I mean that's apocalyptic for that area. I do not think that is generally a highly likely thing to happen. It could, who knows? But it's certainly something to keep an eye on, and it's always good to have that understanding going forward more than a week in advance. And then we'll take a look, and this is another important thing that you want to always end on when it comes to threats for ice, and it's soil temperature. Soil, obviously ice does a lot better if the soil underneath it is very, very cold. So we're looking for this one little line here between the greens and the blues that denotes soil that is, generally speaking, frozen, or at least in a kind of permafrosty kind of region of space. So the closer and closer that the southeast gets to that black line between green and blue is when you really have to be concerned for accumulating snowfall and ice. And we'll see as we move forward into, what is this? This is the GFS model, so it's going to be a little different than what we're looking at with the Euro, but definitely something more to keep an eye on as we move forward in time. So yeah, that's what we're looking forward to. Big jet streak energy that's going to create quite a bit of problems for us here. As I said, definitely pay attention to your local National Weather Service office. It's going to be quite a dicey 36 hours here in the deep south and the southeast. Just definitely have something handy to get your weather warnings and whatnot so that everyone can stay safe. All right, this has been a Gray Atmosphere. I look forward to talking more about this, probably in a more Nowcast live scenario. I'm not going to go live, obviously, but I'm going to try to make a video before the main squall gets here into the greater southeast region tomorrow. And we'll see where we are from there. Until then, everybody stay safe, and I'll see you tomorrow. Bye-bye.